Hello viewers, in today's session we are going to discuss an important problem from application of derivatives, and here we are going to discuss this problem where we have to prove that the function f of x, that is equal to 2x minus sine square x, is an increasing function for all values of x belonging to the set of real numbers. So now to prove that this function is an increasing function, let us quickly see the definition of an increasing function in terms of derivatives. Suppose we have a function, say y is equal to f of x, which is defined in some domain D, right? Now, if the derivative of this function y is equal to f of x, that is f prime of x, is greater than 0 for all values of x belonging to the domain, then the function is said to be an increasing function, right? So here f of x is said to be an increasing function if the derivative, that is f prime of x, is always a positive quantity for all values of x belonging to the domain. So here f prime of x can also be written as dy over dx, right? So here we'll use this definition to prove that this function is an increasing function for all values of x belonging to R. So here we can easily see that the domain of this function is the set of all real numbers. So here the domain is R, right? Now let us differentiate this function with respect to x. So f prime of x is given by d by dx of 2x, and then we have d by dx of sine square x. Now f prime of x is given by 2 times 1. The derivative of x with respect to x is 1, and here we have the derivative of sine square x as 2 sine x, and then by chain rule the derivative of sine x is cosine x. So now we have f prime of x is equal to 2 minus 2 sine x cos x is sine 2x. So this is the double angle formula for sine 2x, because we know sine 2 theta is 2 sine theta cosine theta. So now this is the expression for the derivative of the function f of x. So now let us make use of some concept from trigonometry. Now see, sine 2 theta, sine 2 theta is always going to be greater than or equal to minus 1, but less than or equal to plus 1, right? Because we know that the range of sine function is from minus 1 to 1. So here we have sine 2x. Now the value of sine 2x is greater than or equal to minus 1, but less than or equal to plus 1, right? So let us use this inequality to prove that this function f of x is an increasing function. So let us multiply this inequality throughout by minus 1. So here we have plus 1, and the direction of the inequality get reversed. So here we have minus sine 2x, and here we have minus 1, right? So now here we have 2 minus sine 2x. So to get this expression, let us add 2 throughout, right? So adding 2 throughout in this inequality, we have here 2 plus 1, here we have 2 minus sine 2x, and here we have minus 1 plus 2. So 2 plus 1 is 3, and here we have 2 minus sine 2x can be replaced by f prime of x, and here we have 2 minus 1 is equal to 1. So we can also write this inequality like this, that is f prime of x is greater than or equal to 1, but it is less than or equal to 3. So now from this inequality, we can easily conclude that the derivative, that is f prime of x, is equal to 1 or equal to 3, and it lies in the interval that is 1 to 3, where both these endpoints are included, right? And f prime of x is always going to be positive, because here the value of f prime of x lies in this interval, that is from positive 1 to positive 3, for all values of x belonging to R, right? So f prime of x is a positive quantity for all values of x belonging to the set of real numbers, because f prime of x has the value lying between 1 and 3, and both these numbers are positive, right? So we can now write here f prime of x is always greater than 0 for all x belonging to R, right? So from the definition of increasing function, f prime of x should be greater than 0 for all x belonging to the domain. So here we have proved that the derivative is always a positive quantity for all x belonging to R. Hence we can say that this function is an increasing function for all x belonging to R. Hello viewers, in today's session we are going to discuss an important problem from increasing functions. So here we have this problem where we have to prove that the function f of x, which is equal to 3x minus sine x, is an increasing function for all x belonging to the set of real numbers, right? So before solving this problem, let us first quickly see the definition of increasing function in terms of derivative. Suppose we have a function, say y is equal to f of x, which is defined in some domain D, right? And if the derivative of this function, that is f prime of x, is greater than 0 for all x belonging to the domain, then the function y is equal to f of x is said to be an increasing function. So here if the derivative, that is dy over dx, that is the slope, is always greater than 0, or this quantity is always a positive quantity for all x belonging to D, then the function y is equal to f of x is said to be an increasing function. So here will prove this function to be an increasing function using this definition, right? So let us here find out the derivative of f of x, right? So f prime of x is given by d by dx of 3x, and then we have d by dx of sine x. Now f prime of x is equal to 3 times 1, because we can take this 3 outside this derivative operator, and the derivative of x with respect to x is 1, and the derivative of sine x is cosine x, right? So f prime of x is now equal to 3 minus cosine x. So now we have to show that this derivative is always a positive quantity for all x belonging to R. So for this we have to take help from trigonometry. So here we have cosine x, and we know that the range of cosine function is given by this interval, that is minus 1 to 1. So we can now here write cosine x greater than or equal to -1 but less than or equal to 1. And remember here the domain of this function is the set of all real numbers, right? So let us start with this inequality. So here we have negative cosine x. So let us multiply this inequality throughout by -1. So here we have +1, here we have minus cosine x, and here we have -1, and the direction of the inequality gets reversed, right? So we can also write this inequality as -1, and then we have minus cosine x, and then we have here +1, right? Okay, so here we have 3 minus cos x. So let us add 3 throughout this inequality. So we have -1 plus 3. Then here we have 3 minus cosine x. And here we have 1 plus 3. So 3 minus 1 is 2. And 3 minus cos x is given by the derivative, that is f prime of x, and here 3 plus 1 is 4. So from this inequality we can easily conclude that the derivative it lies in the interval, that is 2 comma 4 for all x belonging to the set of real numbers. So now from this interval, we can easily conclude that the derivative f prime of x belongs to this interval, and here 2 is a positive quantity and 4 is also a positive quantity, right? So f prime of x is always going to be a positive quantity for all x belonging to R, because here 2 is positive and 4 is also positive, and the derivative is having values between these two numbers, including 2 and 4, right? So f prime of x is always a positive quantity for all x belonging to R. And from this definition now we can easily claim that the function f of x is an increasing function, because the derivative is always a positive quantity as f prime of x belongs to this interval. So f of x is an increasing function for all x belonging to R.